Welcome everyone. Today we will discuss about descriptive statistics. Now descriptive statistics is a way to describe your data. So there are various characteristics of the data that helps us to understand the data set better and to treat it in a well manner. Let's say we have 5 observations of male patients and we have observed about their heart rate and blood pressure, right? So heart rate obviously changes and blood pressure will also change, and we want to classify or characterize this set of information. So 5 different patients, the let's say H1, H2, H3, H4 and H5, and for blood pressure similarly we have B1, B2, B3, B4 and B5. Now one obvious thing is, out of this all 5 observation about heart rate, let's say I am interested in what is the minimum it can go. So minimum is a characteristics of this set of information. Similarly, what can be the maximum value, right? So maximum is also a particular characteristics. We can also find out the minimum of blood pressure and maximum of blood pressure. So minimum and maximum, in a simple word, is a character of this information, this set of information. Now set of information we also known as data, right? So to data regarding heart rate and blood pressure, we can find out what is the minimum, what is the maximum. So these are the simplest characteristic of a data set. Next thing, we may be interested in what is the average, what on an average is the heart rate, or what is on an average the blood pressure, right? Average is another characteristics, right? Next thing, you may be interested what value lies at the exact midpoint, right? So if I arrange the values in a increasing order, what is the exact midpoint, right? So that is midpoint. So that is another observation or another characteristics. So far we have found out that there can be, in a very simple way, minimum and maximum are 2 characteristics. Average is also a characteristics, and the midpoint of those values is also a characteristics, right? These all helps us to identify the data set or to visualize the data set or to know the data set better. So all these characteristics are called descriptive statistics. Now why the word descriptive? Because it describes the data set. If I have to give a better example or the better use of this descriptive statistics, say a person is known by its name, right? So there is a person, and this person, the first thing that we want to know about any person is what is his name, right? Now name is also 2-part thing, right? First name and second name, last name. So if you only know his first name, let's say his first name is John, right? Now there will be so many people with the name John. So only knowing the name John is not enough to identify this person from a larger group of people living in a particular state or district or a country or whatsoever, right? So only knowing his first name is not enough for us. The next instinct is knowing his last name, right? So if you know the last name, let's say the last name is XYZ, there may be so many people with the name John XYZ out of this entire people. So next we will try to find out his age or date of birth. The date of birth, there may be more than 1 people with the same date of birth, right? The next thing, we are actually trying to narrow it down. So next step will be to know his either parents name, either father name or mother name, etc., etc. If that is also confusing, or if it also does not help us to narrow down to a single person, next step will be his location or address. Next step will be to find out more information about that particular person, let's say blood group, etc., etc. So all these things, all this information like age, name, father's name, the address, the blood group, etc., etc., are some characteristics of this particular person that we are trying to locate. And these characteristics helps us to find out this particular person or to picture this particular person from a good group of larger group, right? So similarly in data or in numbers also, we have certain characteristics that helps us to identify a particular data set. This data set can be identified or can be distinguished from a larger data set or from a pool of other data sets with the help of certain characteristics. Those characteristics are called descriptive statistics. So under descriptive statistics, we will learn two different branches. That means there are two different branches of descriptive statistics. To be brief, one is called measures of central tendency, and the next one is called measures of dispersion. Right? So descriptive statistics broadly are of two types. One is called measures of central tendency, one is called measures of dispersion. Now measures of central tendency deals with the center of a data set, the midpoint, the average, etc., etc. all of them are measures of central tendency. So under measures of central tendency, we will study mean, which is also known as average, and median. So we will learn about these two things. And under this measures of dispersion, now measures of central tendency is trying to find out the center of a data set, where the center lies, and measures of dispersion is trying to find out how much these numbers vary, how they are fluctuating. So under dispersion, we will study range, variance, and standard deviation. Standard deviation. Okay, let us start with the simplest one, is the mean, right? So mean or average. We will start with mean or average. Now mean are of three types. One is called arithmetic mean, the next one is called geometric mean, and the third one is called harmonic mean. Right? Arithmetic mean AM, geometric mean, and harmonic mean. So these are three different types of mean. Now the core purpose of mean is to find out what is the center of a data set or the midpoint of a data set. So basically, if you draw a data set, if the data set are something like this, so you are trying to find out where is the center or what value lies at the middle or at the center of the data set. So these three are mean, and we will also learn about median. So let's start with arithmetic mean, and I know most of you already know what is arithmetic mean. Arithmetic mean AM. So now let me go back and discuss something before going to arithmetic mean, a quick review or quick idea about grouped and ungrouped data. Grouped and ungrouped data. Now we know data is nothing but information. So let's say the information we are interested in is age of, let's say, 10 students. So in a class there are 10 students and we have gone through all of them and asked them about their age, and the class have responded like 19, 20, 20, 19, 20, 18, 21, 19, 19, 20. Right? So these are the values. Now if you keep the values as it is, how you record it, we have not treated this data anything else, just simple raw data, just simply writing down the data without any classification, without any grouping or merging, etc., etc. This type of data is called ungrouped data. So we have not grouped this data. Now obviously this is 10 observations, so it is quite convenient to write down in a series. But imagine if you have 1000 data, then writing down 1000 numbers in a sheet is not convenient to look at or to judge or to process, right? In such a situation, we always prefer to merge them or to make them concise. So grouping is a way of concising or reducing the volume of your data set. So in this situation, we can write that we can count how many of them has the lowest age is 18. So age 18, number of students, there are one student with the age 18. 19, there are 1, 2, 3, 4. So there are 4 students with the age 19. 20 is 1, 2, 3, 4. So there are 4 students with the age 20, and for the age 21 there are 1 student. Now when we group this, the total should be the number of observations, right? So this kind of grouping is called grouped data. Grouped data, right? Now group data are also two types. One is discrete and one is continuous. Now when discrete is when you are grouping the values. Now this was our raw data, right? Our original data. If you write it like this, it is called ungrouped data. Now we are trying to process it and trying to reduce the volume, right? So in the process of reducing it, if you are considering individual ages and counting how many items are there in this individual ages, that will be called a discrete frequency table or discrete grouped data. Now if this age, now if you are asking, now this situation involves students. So we know that for a particular class or a particular section, the possible age group will be for a very short range, right? Now in this case it is from 18 to 21. Now if the situation is different, if we are asking age of, let's say, patients, right? Patients of a particular hospital. Now there are possibilities that there will be infants, right, with age 1 or 0, and there will be very elderly people with age maybe 85 plus, right? So the possible range of age is from 0 to 85. Now if you count how many patients are there for age 0, age 1, age 2, age 3, so in such a case the possible table or for the discrete grouped data will be a very big table, right? That will be a very long table, and it is in no way concise or in no way reducing the volume of the data. So what we do, we make groups, right? In such a case, when the possible observations or possible range of observations is large, we group the range, right? We make certain groups. So if we are dealing with the age of patients, then in such a case we can make certain classes. Let's say 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and so on, right? So any person whose age, any patient whose age lies between 0 to 10 will be marked or will be counted in this group. Similarly, any person whose age is between 10 to 20 will be marked in this group, 20 to 30, 30 to 40, etc., etc. So this kind of classification or table is called continuous frequency table or continuous grouped data, right? So one is raw data or ungrouped data, when we are not making them in terms of tables or creating tables from them. One is when we consider individual items, that is called discrete frequency table or discrete group data. One is when we take ranges, right? Certain range and find out how many people belongs to that group, right? So that is continuous. So these three are different types of data. Now let's go back to arithmetic mean, right? So the definition is, let x1, x2 up to xn are n observations. What observations means? Data, right? Let x1, x2, xn. x1, x2, xn are generic terms used to describe a data set. Rather than using actual values, we use x1, x2 up to xn are n observations. Then the arithmetic mean. Now arithmetic mean normally is denoted by x, and the line above is called x bar, right? Is denoted by x bar, is given by ratio of sum of the observations to the total number of observations. X bar is x1 plus x2 up to xn divided by n, which is in short written as 1 by n summation I goes from 1 to n x I, right? So this is the symbol. Now what is summation symbol? I guess you are familiar with. Summation I goes from 1 to n xi is nothing but we will replace the value of I at every step. That means at the first step it will be 1 plus at the second step it will be 2 up to what? Up to this last value, that is xn. So this is the definition of arithmetic mean in case the observations are ungrouped, right? This raw data. Let x1, x2, xn are n observations. Then the arithmetic mean is given by the ratio of sum of the observations to the total number of observations. So this is the definition. Now in case of grouped data, let x1, x2, xn are n observations with frequencies f1, f2 up to fn. Now what is frequency? Frequency is nothing but how many times x1 is repeated, or number of repetition. Frequency is nothing but number of repetition. Number of repetition. Okay, so in case of group data, let x1, x2, xn are n observation with frequencies f1, f2, fn. Then the arithmetic mean x bar is x bar equal to x1 into f1 plus x2 into f2 xn into fn divided by f1, f2 up to fn, or in short, summation I goes from 1 to n xi fi, summation I goes from 1 to n fi, which is equal to summation xi fi I goes from 1 to n. This summation f in short is written as capital N. So this is the formula. So the two formulas, arithmetic mean in case of discrete data or ungrouped data, it is I goes from 1 to n xi, summation xi, right? And in case of grouped frequency, this is 1 by capital N, summation I goes from 1 to n xi fi. So remember these two formula. So out of all these means, that means arithmetic mean, geometric mean and harmonic mean, arithmetic mean is the most popular and most frequently used due to it is the best, it is called the best measure of central tendency, right? So we will most frequently use arithmetic mean because of its properties or because of its advantages, right? So these two are the formulas. Let us give an example. So if the values are 7, 8, 6, 5 and 10, then arithmetic mean will be 7 plus 8 plus 6 plus 5 plus 10 divided by number of observation, which is 5. So this is equal to, so this is 36 and divided by 5, which is 7.2. So this is arithmetic mean for ungrouped data. Next, let's say there are A's and there are number of student and the ages are 18, 18, 19, 20, 21, 5, 4, 4 and 7, right? So these are called frequencies. That means this is x1, this is x2, this is x3, this is x4, this is f1, this is f2, this is f3, this is f4, right? So this is for group frequency. So x bar will be x1 f1 plus x2 f2 plus x3 f3 plus x4 f4 f1 plus f2 plus f3 plus f4. So the values will be 18 into 5 plus 19 into 4 plus 20 into 4 plus 21 into 7 divided by 5 plus 4 plus 4 plus 7. So this is equal to, so this one will be 393, this is 20, so the value will be 19.65. So that means in this data set, the age varies from 18 years to 21 years, right? So there are 5 people with the age 18, 4 people with the age 19, 4 people with the age 20, and 7 people with the age 21. So all of this, if we calculate, we found out that the average age of those, let's say, students, all of those 20 students is 19.65, right? So 19.65 is the value that represents the center for this particular data set, right? So this is one way of calculating arithmetic mean. And the third example will be, so age and number of, let's say, patient, number of patient. So 0 to 10, 10 to 20, 20 to 30, and 30 to 40. So there are, let's say, 5 patients in the age group 0 to 10, 10 patients in 10 to 20, 10 patients, and 5 patients. So now in this example, our formula requires x1, x2, x3, and x4, f1, f2, f3, and f4, right? So obviously this one over here is f1, this one over here is f2, this one over here is f3, and this one over here is f4. But we don't have exact value for x1, right? x1, x2, x3, x4. We don't know what is x1 because we have two values here, 0 and 10. So we need x1. So that's why we create another table here, right? So we will have to create another table. The table will be called, mid values, and mid values represent x in case of continuous group. Now what is the mid value? The midpoint of these two, or the average. 10, 0, the middlemost will be 5. 20, 10, the middlemost will be 15. 20, 30, the middlemost will be 25 and 35. How to find out? Simply 0 plus 10 divided by 2. 10 plus 20 divided by 2. 20 plus 30 divided by 2, and 30 plus 40 divided by 2. So this will be now our x1, x2, x3, and x4, right? Now the next thing is similar to our last example. So we will have to find out x1 f1 plus x2 f2 plus x3 f3 plus x4 f4 divided by f1 plus f2 f3 plus f4. This will give us the arithmetic mean. Now x1 is 5 into f1, this is f1, so 5, then 15 into 10 plus 25 into 10 plus 35 into 5. f1 is 5 plus 10 plus 10 plus 5, right? So this is 25, 150, 250 plus, and 35 into 5 is 175, and the total frequency will be 30, and the answer is 20. So the average age of this data set, that means where we have 5 people from 0 to 10, 10 people from 10 to 20, 10 people from 20 to 30, and 5 people from 30 to 40, the average age is found out to be 20 years, right? So this is how we calculate arithmetic mean for a different types of data set: ungrouped, discrete grouped, and continuous group, right? So that's all for this class. In the next class we will discuss about geometric mean and harmonic mean, and then we will go to median, and then we will move to this dispersion, that is standard deviation, range, and variance.